Hello. Today we are going to learn blockchain consensus mechanisms and mining in blockchain. In Module 6 we have these topics: 1. Proof of work POW, Proof of stake POS, and other consensus mechanisms. 2. Mining and transaction validation in blockchain. 3. Energy consumption and scalability issues in blockchain. Proof of work POW and proof of stake POS are two of the most widely used consensus mechanisms in blockchain technology. POW is a consensus mechanism that requires miners to solve complex mathematical puzzles to validate transactions and add new blocks to the blockchain. The first miner to solve the puzzle is rewarded with newly minted cryptocurrency. This process is computationally intensive and requires a significant amount of energy. POS, on the other hand, is a consensus mechanism that relies on the stake or ownership of cryptocurrency by validators to secure the network and validate transactions. Validators are chosen to create new blocks based on the amount of cryptocurrency they hold, and they are incentivized to act in the best interest of the network, as they stand to lose their stake if they validate fraudulent transactions. Other consensus mechanisms include delegated proof of stake (DPS), which relies on a small group of elected validators to secure the network, and Byzantine fault tolerance (BFT), which relies on a quorum of nodes to reach consensus through a voting process. Mining and transaction validation are critical processes in blockchain technology that ensure the integrity and security of the system in a blockchain network. Transactions are validated and added to a block by miners who compete to solve a complex mathematical problem using computational power. The first miner to solve the problem and validate the block is rewarded with a predetermined amount of cryptocurrency. Once a block is validated, it is added to the existing chain of blocks in a linear and chronological manner, forming an immutable and tamper-proof ledger. Each block contains a cryptographic hash of the previous block, creating a chain of blocks that cannot be altered without invalidating the entire chain. Transaction validation involves verifying the authenticity and validity of each transaction before adding it to the block. Nodes on the network participate in the validation process by checking the transaction details, such as the sender's account balance and the transaction amount, to ensure that they comply with the network's rules and regulations. Overall, mining and transaction validation are crucial components of blockchain technology that ensure the system's security, decentralization, and immutability. One of the major concerns with blockchain technology is energy consumption required for mining and transaction validation. Proof of work POW consensus mechanism, used by popular cryptocurrencies such as Bitcoin and Ethereum, requires significant computational power, leading to a high energy cost. This energy consumption has raised environmental concerns as well. To address this issue, various alternative consensus mechanisms have been proposed, such as proof of stake POS, which requires validators to hold a certain amount of cryptocurrency as a stake instead of solving complex mathematical problems. Other mechanisms, such as delegated proof of stake (DPS) and Byzantine fault tolerance (BFT), have also been proposed as more energy-efficient alternatives to POW. In addition to energy consumption, scalability is another issue in blockchain technology. As the number of users and transactions increases, the network may become congested, leading to slow transaction processing times and high fees. Various solutions, such as sharding and off-chain transactions, have been proposed to address scalability concerns. Thank you for watching. Use was last part of our course.